Alright class, we're doing direct variation today. It's 4.6. You guys can kind of follow along with me as I go through the guided notes here. It says an equation represents direct variation if it can be written in the form of y equals mx plus b. And again, we know that this here is slope-intercept form. Okay, along with that it says y varies directly with x is written as y equals ax. So the one thing I wanted to bring to your attention is that a and m are the same thing really here in this equation. M is still our slope, but we have some different notation for today, but in terms of how we solve it, it's no different. And then what we have here, this new variable, the new variable a is called the constant of variation. So when it asks for identifying the constant of variation, really what they're asking you to find is the slope. What I'll do here is I'll try example 1 and I'll kind of talk through it as I do it, and then I'll let you guys pause it if you'd like and try some on your own and then see how you do. So this first one here, again, I need it to look like what I have up top here, y equals ax or y equals mx plus b. Either way, we have to isolate y, so I need to add, or excuse me, not add, I need to subtract 2x from both sides. Now I have 0 minus 2x, but really all I have is negative 3y equals negative 2x, and if you put plus 0 it doesn't change anything, but you really don't need to. Now what I need to do is divide both sides by negative 3 to isolate y the rest of the way, and I end up with y equals negative over a negative is going to be positive 2/3 x. This does in fact model direct variation because all I have in front of it, or all I have on the other side of my equation is the letter in front of x, or the number in front of x. So my constant of variation here, is just 2/3. Okay. The only time it's not going to be direct variation, class, is when you end up with plus or minus something after x. So it should always be 0 here. You don't have to put it, but there shouldn't be anything after the equation on any of them that are going to be direct variations. So just keep that in mind as you work these. Like I said, go ahead and try them on your own, see how you do, and then I'll kind of talk through them here after I finish the problem. So go ahead and take a second to try them on your own. Okay, so I've finished these up, you guys. If you want to just take a look at them after I've already solved them here. So my first equation here, I get y equals x plus 4 when you're done solving for it. Again, we can't have direct variation if we have plus or minus anything after that x there, so that's not direct variation. This one, letter C, is also not direct variation because we have that minus 1 after the x term there. My second letter C here, as I noticed I'd made a typo in the notes, is direct variation because there's nothing after this 2x here. So again, that's really all there is to it. And then we'll start talking about graphing them here in just a second. So whenever I have a direct variation equation, again, you guys, I need to make sure that y is isolated. Up top here, y is already isolated for me. The nice thing about direct variation, you guys, is every single time I look at this, I'm going to see the same thing. If it is direct variation, there's going to be nothing after the x term, which means we can put plus 0. It doesn't change the value, it just helps us kind of see where our intercept is. So if I look here and I have that plus 0, that means if I look at it in terms of slope-intercept form, my y-intercept is 0. Then I just simply use the slope, or my constant of variation, to plot another point. I go up 2 and over 3. There's another point, up 2 and over 3 more, or I can go down 2 and left 3 to plot a point. Basically, here's what the line looks like. So today's graph should be easier, even easier than the ones we did the other day. Like I said, go ahead and take a second, try the other one, and I'll start recording again here in just a moment and show you guys the answer. So the process here is really very quick. Again, the first point on any direct variation problem is going to be at the origin. I use my slope, negative 3 over 1. I go down 3 and right 1. or I can go up 3 and left 1, but either way you can see that my slope is negative. It's very steep because my slope is 3, but again, this is all there is to this problem. Okay, there's actually a couple parts to this problem. So if I look at this, basically we know that these are both direct variation because they're both going right through the origin. Now what I have to do is I have to look at this by looking at what the slope of the line is here. I'm going up 2 and left 1, so my slope is going to be positive 2 over negative 1, or if I want to evaluate this, it's going to be negative 2. Now I can simply plug negative 2 in for a, and my equation looks like this: y equals negative 2x. Then the second part of the problem right here, it says find the value of y when x is equal to 30. So what I'm going to do is I'm going to plug 30 in for x, and I'm just going to say y equals negative 2 times 30, and I simply get y equals negative 60. So if I were to plug in 30 for x or plot 30 for x, the point would be clear at negative 60. So again, go ahead and try letter B, and I will show you it here in just a moment. So this problem, you guys, isn't much different. If you look up here at the picture, we go up 2, so I write positive 2 here, and then from that point we go left 2 to get our second point. So it's positive 2 over negative 2. When I evaluate that, I get negative 1. So my equation, I plug negative 1 in for a because that's my constant of variation. My equation is simply y equals negative 1x. Then I take that equation and I use it down here, and I plug 30 in for x again. Negative 1 times 30, I get y equals negative 30. So again, this part should be, this whole section should be very easy for us. Okay, so I've already kind of highlighted our information here. If I'm going too quickly, you guys can go ahead and kind of pause this and look it over as I've highlighted it here. So I've underlined the tablespoons of sea salt and the 100 tablespoons down here in red. And then when I wrote them in my equation, I wrote them in red also. And then I did my water stuff, my 20-gallon tank, and my W. And I just changed the W to Y and the S to X. That's fine. But we ended up with something that looks like this. And again, if I did it like the instructions say to here, it would look like this: W is equal to 5S. So for every gallon of water, we need 5 tablespoons of salt water, or sea salt, sorry. And that's kind of what we have for our direct variation equation. So what I did was I took it down below and I plugged in 30 for x, just like I did in the previous two problems, and I found my answer to be 150 tablespoons for a 30-gallon tank. I'm going to go ahead and skip this last example, guys, so go ahead and spend the time in class to do the 4.6 quiz in eBackpack. Also, our test is coming up, so if you don't want homework early on next week, you could kind of look ahead and start working on your Chapter 4 practice test also. But again, the rest of class time is yours, so please use it wisely and get the work done. Thanks. Have a good day.